sorry that the recording last night didn't seem to work. I thought sure it was turned on. So probably operator error, but let's go through these factoring problems. And first we're going to talk about which type of polynomial each one is, because noticing what kind of polynomial it is helps you choose what possible factoring strategies might be good choices. So this first one is a trinomial. It's 3 terms, and terms are separated by pluses or minuses. So 7y cubed is one term that has 2 pieces because the 7 is a coefficient, and then the y cubed is the variable part. Okay, so that's a trinomial. So this next guy is also a trinomial, and so is the next one. But then we come to one that only has 2 terms, so it's a binomial. And then you can see that the last one is also a binomial. So we have special names for the 3 term and the 2 term, but we run out of special names, and the 4 term one is just called the 4 term polynomial. So it's a good type. Okay, so now we've identified what type they are. So now let's look at how we would factor them. So the first factoring strategy that you learn is always factor out the greatest common factor. Which we abbreviate. Okay, so I'm going to break this into So you look at all of your 3 terms, and I would notice that they all have a factor of 7. It's 7 and 14 and 21 are all part of the 7 times. So my GCF is going to have a 7 in it, and then it's always the exponent with the smallest, the variable with the smallest exponent. So this is my y. So I can factor out 7y for each of the terms, and I'll end up with y squared minus 3y plus 2. Now there's lots of different ways to factor a part in the parentheses. This again is trinomial. And you're going to factor 2 binomials. And the Algebra Support Center would love to help you with this. There are so many different ways to do it. And then you're going to start so many ways to find so many. And every time you like that. So Algebra Support Center can show you lots of different ways to figure out the different things. So let's look at the purpose of doing this. This original blue writing, I have no idea when this is 0. I can't tell by looking at it. And now that I have factored it, I can tell that this is 0 when y equals 0, y equals 2, and y equals 1. So the purpose of doing the factoring is we're turning it into factors, 1 factor, 2 factors, 3 factors, and if they multiply together to 0, one of them has to be 0, and those numbers that we find are so important to us in calculus, they're called critical. So that's the purpose of factoring, is to be able for us to find critical. Okay, so then D, we said, is a trinomial, and so we know we want to factor it into 2 binomials, and we know we need y and y, and we're going to get y squared as the first term, of the multiplied out result. And then when we multiply these last, I have to get negative 81. So I could have negative 1 and 81, but then they need to add up to negative 18 when I do the inners and outers. And negative 1 and 81 are not going to add up to negative 18. So then let me try 1 and negative 81. Well, that's not going to work. So then 3 divides evenly into 81, so I could have negative 3 and 27. Also doesn't add up to negative 18. How about 3 and negative 27? No, but I'm getting closer. So how about 9 and negative 9? Well, that would give me the multiplied of negative 81, but those do not add up to negative 18. So the answer to this one is 1. It cannot be done. And we conclude that because we tried every possibility and none of them worked. So this is called a proof by exhaustion. I've exhausted the possibilities and it didn't work, therefore there isn't anything else. Okay, let's go on to C. We have 35w squared minus 2w minus 1. I want to show you the method I like to use, called the AC method. Again, there's lots of ways to do these. And as long as you have a way and you can explain it and show them how to do it, it's a good way. So it's called the AC method because the 35 is A and the negative 1 is C. And when A and C are written up against each other in math, it means to multiply them. So AC in this example is negative 35. Well, the way we use this number, I like to make this giant F and I put a multiplier in the top and a plus in the bottom. So I put AC in the top, and I need two numbers that multiply to negative 35 and add up to B. And some people can just see these quickly, and other people just need to do a systematic list. Doesn't matter which one you are, you'll get there. So 1 and negative 35 definitely don't add up to negative 2, and neither do negative 1 and 35. And 3 doesn't divide into 35, neither does 4. The 5 does, but we have 5 and negative 7, or negative 5 and 7. Well, I want them to add up to negative 2. So I need to put 5 and negative 7. Then what I do with the 5 and the negative 7 is I rewrite the middle term as 5 W's minus 7 W's. So I haven't changed anything. I'm just writing it in a new way. And if you can find two subnumbers, this way will work. If you can't find two subnumbers, it doesn't work. Okay, so the reason for doing this is now I have 4 terms, and I do something called factor by grouping. And I look at the first pair, and I see that the GCF of the first pair is 5W. And factor out 5W from the first pair, and get 7W plus 1. Then when there's a minus in the middle of the two pairs, there's a minus in the end. And then these two terms, 7W and 1, have nothing in common, but that means you can factor out a 1, and factoring out negative 1 changes the signs on both of the dots, and if you're receiving that, if this distribute -1, you'll get back to the purple red that started with. Okay, now we need to see that there are two big terms here, and they have a common binomial. So we're going to factor out the common binomial. We make this by W -1, and this is our factor result. Here again, the W is equal to 0, it's U is 0. So let's look at these. And this has a factor out the UCF that needs to come first. And here our UCF is going to be 3A squared. We'll factor out the UCF, we write the UCF and open a bracket. And then say 48 divided by 3, that's 16. A to the 4th divided by A squared minus 1. Well, now this thing is a difference of squares. And it helps some people to factor difference of squares to make it visual of what are the two things that are being squared. And then I'll just remind you, you may have learned this. A squared minus b squared factors as a plus b, a minus b. It's either order, as they represent numbers, as the order of numbers that matter. So we're going to factor this difference of squares as for a plus 1 and for a minus 1, now it's factored 3. And e x cubed plus 2x squared minus 25x minus 75, the only strategy you have for factoring a four-term polynomial is factor by grouping. So you don't really have any options if it's a four-term. It's factor by grouping. You might need to factor out a GCF first. So we pair up and pair up. Here for the GCF of the first pair, it's x squared and x 17. Oops, this is x 3. Oh, that wasn't going to work. And this minus is a minus. 25 and 75 have a common factor of 25. Factoring out the negative, the signs change. And now see the two big terms with a common binomial. Factor out the common binomial. Oh, and then this is a difference of squares. So a lot of these have more than one technique, so that we can practice a lot of techniques and how to do those things. So I'm going to have x plus 3, x plus 5, x minus 5. Now it's completely factored. And the last one is 8x cubed plus 1, and it's a sum of cubes. So if you have a sum of cubes, here's the pattern that we will follow. A, B, A squared, A, B, B squared. And then the sign goes same, opposite, and always opposite. But you will have to memorize this. Or if you need it faster, have some of these. It can be helpful to write it as, oh, that's the quantity 2x cubed plus the number 1 cubed. So that's going to be the a plus the b times a squared plus ab plus c. And just to note, this part never has DOD. No real number. So if you're looking for critical numbers, none of them will come from that second part, but they could come from the first part. So 2x plus 1 equals 0, the product is 0. So if you need any factoring refresh, please take advantage of the Algebra Support Center. Or there's Khan Academy videos. Hopefully I've given you lots of the language that you can look up. Oh, I need to remember some of these. There's different things. There's different things. And they've got lots of little bite-sized 10-minute videos. So please invest in factoring. It's super important. It's why we call the numbers we find critical numbers. They're going to be critical for us to be able to move forward in our process. Hope you have a great rest of the day.